Hey, hi everyone. Good morning. We could wait for one more minute and then let's get started. Hey, while we wait, Marian, you could start sharing the screen. I think we will start with your PL, and then perhaps Kumaresh could help to recap why we have this PL. Okay, we'll get started now. Yeah. Marian or Kumaresh, we cannot hear you.
Hi, Rita.
Hey, hi, Marian. Yeah.
Is the call being recorded, Rita?
Yes. Yeah, so Marian is gonna go walk through the PR, move the tunnel decapsulation before L2, L3.
So we can start?
Yeah.
Okay, thanks. Right. So this pull request updates Visio document with the behavioral model. So I would like to start with explaining where we found the problem and what were the implications on software. On software side of SAI application. So what I'm showing right now is the current behavioral model for the tunnel decay. It has the following order. You've got the port domain. From port, you can go to the router domain, and only from the router domain you can get to the tunnel decapsulation table. So this one, doesn't seem to have a problem on its own. However, if you combine it together with the ACLs, we see that there are complications in terms of how all of this, how ACLs have to be managed together with the tunnel decap. So just for reference, I have added the example with 2 packets. So this is the use case that we observed it. We have essentially the same packet that can appear in 2 different forms. First case would be it's the packet on its own, and this is the packet that user intended his ACL rules for. And another form would be the packet with additional tunnel encapsulation that came from, let's say, peering device that serves essentially the same role in the network, but it bounces the packet to our device. And what we have is a packet could have arrived on its own from the upper tier of the switches, or it could have been bounced from the same tier. And if we follow this model, we have our pre-ingress, ingress ACLs. So over here, the packets are untouched. So we get to the router, the packets are still untouched. And we essentially went through the ACLs that the user defined binding to. And packets are still untouched, and we got to the tunnel decap table, after which the packets, the upper packet was decapsulated. So the difference here is that this ACL table is, we'll see 2 different packets. First one is the one that was intended. Second one is the bounce back, and there won't be any match on this packet because it is hidden behind the tunnel. So this one will be, let's say, ignored by the ACL. We will get the same packet only after tunnel decap over here. So the way to solve or to manage ACL in this type of behavioral model would be to do an explicit binding already after the tunnel, and over there essentially bind the same table after the tunnel, so we could capture this packet that was decapsulated as well, and the behavior would be consistent for both scenarios. And the problem that we see is that now we don't really have this, let's say, best user experience, because there is a portion of the software that manages ACLs, and there is a portion of the software that manages tunnels. They can be, let's say, entities that don't really talk to one another that much, and they don't need to. However, this model requires you to keep track of the tunnels, and whenever the tunnel will be added, you need to carefully manage the binding of the ACL so that you won't miss stuff like that. So, which prompted us to look into different directions, and we asked other vendors how they interpret this, because this was by the way, like we noticed on real life examples that there is a difference in behavior. So there is another way to go about the order of tunnel decapsulation. And so this is the updated version of tunnel decapsulation, which moves it like from the looking at it from further distance. It simply what it does, it moves tunnel decapsulation all the way back into the beginning of the pipeline. And in this case, what you have is your pre-ingress, which is this portion isn't changed. Then if you have a tunneled packet that is meant to be decapsulated, meaning that we have tunnel decap entry in the tunnel decap table. And we'll go through the tunnel decap flow, all these purple blocks. We'll get here, same as before, but much earlier. Before we get to layer 2, layer 3 domains. And if not, then it will be just like transit case. You don't touch a packet and it gets over here as well. So this is the proposed change and hold on. This is like the extra copy of it, but with the packet, just to have this example. So we have those two cases. The regular packet will go through. There will be no entry in the tunnel decap table, so it will go straight over here. So the behavior for this one is unchanged. You go to blue, and from blue you go to yellow. But for the tunneled packet that is meant to be decapsulated, you hit the tunnel decap entry earlier. I also, by the way, updated match criteria because it's we noticed it's a little outdated. So now it has a different SIP and a tunnel type, of course. After that, you go to the tunnel table, which will indicate that we need to do the decap and also point to the mapper table. So mapper table is what we know, and we already have like the SAI API for that. It's different kinds of mappings that we might have. So for example, in this case, like if it's a VXLAN tunnel, and for instance, we wanted to go to router after decap, so it would be L3 VNI. We would map it to URF and so on. But before that, we will do decap, and after decap, like, we get the same packet, and then there will be a choice. We either go to layer 2 domain if that is what was mapped in the tunnel. In that case, there will be the ingress ACL on the layer 2 on the bridge. If it's a layer 3 domain, as it is depicted in this diagram, then both packets will go to the ingress. We'll have a lookup on the ingress ACL in layer 3 in the router domain. Yeah, so this is the proposed change which aligns behavior for two types of packets, the one that is decapsulated and the one that isn't. Other cases, as far as I looked at, shouldn't be affected.
So, Marian, do you want to update the package stages as well, like ingress and ingress?
Sorry, Commerce, could you repeat that? I can barely hear you.
Do you want to update the ATIC stages, like a pre-ingress and ingress in this diagram?
Oh, you know what? Yeah, right. So all over the Visio, they don't have the names. Probably we need to put them. Yeah.
Yeah. I think
That's
that
right.
will make it clear. Yeah.
Okay.
Thanks.
Marian, just to make sure I really understood this right. So what we are saying is, in the pre-ingress stage, there'll be difference in what we observe. The tunnel packet versus a normal packet in the pre-ingress stage. But after that, in the ingress stage and the egress stage, both the tunnel packet that gets decapsulated and a normal packet, both will look similar.
Right. Yeah. So over here in pre-ingress, packet is observed still as the original packet, hence the name pre-ingress. But then when you get over here to ingress, yeah, now you get it after decay.
Okay. And what doesn't come out here is right. The new proposal which Kamlesh was saying is we'll introduce a new match qualifier saying is tunnel terminated. Basically the decap flow, right? The packet can
New metadata. Probably, yeah, I could add that. Like it's over here, you would have another metadata added. Tunnel
only for the
termination.
tunnel terminal. Okay.
Yeah, for this.
Yeah, I think so. That proposal was like mainly to focus on if the match criteria is same, but let's say if we have like two different actions, so we want to match whether the packet is tunnel terminated or like just like a regular packet, and then want to have like a two different actions. So the previous one was to have the tunnel bind point, but I think instead of that, we'll just add a new attribute and then we'll just match on that part. Yeah, I think
Okay.
I will add that attribute and create a new PR later.
Okay. And that attribute will be based on this metadata for the tunnel flows. Whenever we go via this tunnel decap flow, on those packets, this metadata would be set.
Yeah.
Yeah, so it's roughly over here. If we decap.
So Kumresh, will that be enough for cases where you have multiple types of tunnels getting terminated, or even, for example, GRE and VXLAN getting terminated, or even for VXLAN, you might have cases where you have tunnel termination coming from outside versus inside, like, right? And you may want to differentiate between the tunnels originated from outside the data center, let's say, versus inside. Would a bit enough, or do we need something like a field to say, it's not a decap and what kind of tunnel was decapsulated?
We already have the metadata with the tunnel type.
So the type will always, let's say, only say GRE versus VXLAN, right? But there are cases like DCI, data center interconnect, where typically people differentiate between tunnels which originated outside the data center versus inside, right?
You're saying we created more than one tunnel, and depending on which tunnel decap entry we hit, we'll get another inside terminology and not a different tunnel object ID.
Yeah, it could not. I mean, I'm just saying that a single bit tunnel decap may not be enough. You may need more than a single bit. Like the tunnel decap is true with a single flag, right? You may need something like a field, or maybe the tunnel ID is enough to solve that problem, but it's not clear that tunnel ID itself is enough.
Yeah, I think
and a typical use case will be DCI, the data center interconnect.
Yeah, in some cases, like for example, in smart switch cases, right? Because the tunnel is from the other T1, so we can most likely it would be just the VXLAN, and we could have like other match criteria like match on the other other IP fields to make sure that okay this packet is from the other T1. But yeah, I think you are right. Like in case if you want to have like a multiple different types case if you want to have like a different set of tunnel types, then we can have another flag.
Okay. Yeah, we can add it later when
Yeah.
there's more specific use case for it.
Yeah.
Yeah, Kumaresh, I don't understand why do you need that? So tunnel is a tunnel, right? Whether it's originated within the data center or is being terminated across DCI.
No, I think
How does it matter?
no, I think the use case is like, suppose if you want to match on only a specific type of tunnel, right?
What is type? Type as in the
Like
VXLAN GRE or
IP and IP.
okay, so it's type like IP and IP, GRE, VXLAN, etc. Okay, so that's the type of the tunnel. All right.
Yeah. So just to want to make sure, like if you want to match only on the VXLAN, let's say there is a use case, right? And where you can say like a tunnel terminate flag, and you can also have the tunnel type, right?
Right. But for that, you already have a UDP desk port, right? Why would you?
Jay, I was thinking more about the use cases. Something like, for example, some of the use cases I've seen is like sometimes people want to learn only from the tunnels which originated within a data center, and not from outside the data center, because the learning for tunnel outside the data center is done through BGP, let's say. But
right.
So those are the cases you may need additional.
I understand, but those tunnels are typically well defined, either using a VNID or some other packet fields.
Yeah, exactly.
You don't need another type bit.
No, not bit in the result, not in the. So let's say you match on VNI, right? Because it was using a specific VNI or a specific set of VNIs for those, right? So then you go to this tunnel mapper table, let's say, which matches on VNI, right? That's the only table which matches on VNI. And it will output another flag or something saying don't run.
Correct. But then you can set internal metadata, right?
Well, that is what I'm saying.
Yeah. But
so that's what I'm saying. We may need more metadata than the tunnel decap is true.
Right, exactly. But that's already there. You don't need a new. That match on metadata is already present.
Match is present, but setting of metadata is what I'm talking.
Even on setting is present. That would be set by the previous stage, right? So let's say the tunnel decap is happening. At that time, you do the match on the tunnel headers. You have all the tunnel headers, and you can set the metadata at that stage, which is the pre-ingress stage. And once you have the metadata, then you can use it as a match criteria anywhere follow on.
Yeah, and what I'm saying is that because we explicitly adding this metadata tunnel decap is true, right? That could also have been set at the tunnel decap table, right? Because that's where you decide to decap the tunnel. So what I was pointing out is there may be other use cases other than the single flag. You will set it in the tunnel decap table, that is true, or in one of the three tables we have shown here.
Right. Yeah, but just a match on method. So Marian, we already have that match criteria, right, on a metadata?
No.
Tunnel decapsulated?
No, currently I don't think we have any metadata to match the tunnel termination.
In the tunnel decap case, we are talking about the ACLs, right?
Yeah.
I thought we have a match on metadata. I mean, that's the whole point. Otherwise, we can verify it. We can come back on it. But as far as I recall, the whole concept is any stage, ACL stage, can spit out the metadata, which can be used by the following stage.
Is it a user metadata that you were talking?
Yeah, user metadata, right.
I thought that was mainly to pass between ingress and egress.
You can use even between stages as well, but we can take a look.
Okay.
But there is a concept of metadata, which is opaque information and can be used as a vendor specific way, as well as the use case which you are defining. Because typically, there is no concept of external tunnels and internal tunnels explicitly. Even in SAI, there is no such thing. It's all derived based on some IP addressing or VNID.
Yeah, I think currently we have the metadata setting in the ACL, but I don't think we have any metadata setting in the tunnel decapsulation table.
Okay,
yeah,
we can take a look at that.
Yeah, if we add that you set user metadata action in the tunnel decap table, right?
Yeah.
It solves the problem because people who need that feature can simply use it.
Right. Yeah, that if it's not there, we can do that. Definitely, I agree.
Yeah.
Hey,
I think,
sorry, I had one more question. Like for the how is the outer verf derived here? Like somewhere you have to derive an outer verf for the tunnel, right? Isn't that the case? Like should we not have an outer verf here to do a tunnel decap?
It's the VRF is from the tunnel mapper table.
No, but that's the inner VRF, right? I think Krishna is asking about the outer VRF, which you need to scope dip and sip for the tunnel decap table.
There is no outer VRF because we do decap before the router domain. Unless you're talking about the case that we don't do tunnel decapsulation.
So basically, we are assuming that all tunnels are in the same VRF, or global VRF or something like that. The tunnel IP addresses are in global VRF.
I think that's the SAI model, I guess, right? We just have either you can have a SIP comma dip or just the tunnel term entry the way it's defined today, right? It doesn't take out VRF.
No, but it derives a riff though, right? Like the outer riff can have different verfs, is what I thought. Like you can have an outer riff and inner riff. An outer riff can give you a different verf than the inner.
Okay. The key to terminate the tunnel, right? That is only based on SIP and dip. It doesn't take anything else, right? In the sense that the key is today isn't like a VRF comma SIP comma dip. The tunnel term entry, right? Whatever is inside the tunnel term entry, the way it's defined, it will.
Yeah, so that's Krishna's point, right? That assumes that all the tunnels are in the default verf.
Global, yeah, in the default verf.
Did we lose any functionality from before then?
I don't think so. Today, right? Today, the way it's defined is source IP, dest IP. That's all it takes for tunnel term. Let me check the tunnel term.
Yeah, I don't think we lose any functionality. That's the SAI model for tunnels. Tunnels today, we cannot do any lookup on a VRF, which is on a tunnel riff.
Okay.
Krishna, is there a use case for you? I mean, that's a separate discussion completely. Where the tunnels are terminated coming in on a VRF?
No. We didn't have a use case. I think the previous company, like we did have like where like we have to derive two different verfs for us, like one for outer, one for inner. So that's why, yeah. I was under the same assumption that like we're also losing some functionality here. If that's not the case, maybe think okay.
Yeah, because SAI model is a little bit different. In SAI, if you see that we don't have, the tunnel comes on a port, and then port has a binding to VRF, etc., right? But that port binding to VRF becomes active only after the tunnel decap, or if it's a tunnel transit case, right? Like Marianne was pointing, if it's a transit case, then yeah, port VRF will be active. If it's a decap case, then after the decap, the VRF becomes active on that port, if tunnel is coming on that port. But typically, we don't do...
After decap, you use the VRF.
Sorry,
that was mapped. After decap, the VRF is used from tunnel mapping table.
Correct. Yeah.
Okay.
But it will be a tunnel mapping table, but mapper is... What's the binding of a mapper? I don't recall. Is it a port or?
No, it's a tunnel.
It's a tunnel. So then a tunnel coming in on any port will get a VRF, right?
Same VRF, because we don't use port in the tunnel decap table, right? So then it cannot give you a separate tunnel ID based on the port. And if you don't get a separate tunnel ID, then you cannot bind it to a different mapper. So the net result is that doesn't matter which port the packet came in on, you'll basically derive the same inner VRF because there's no... This port is not there anywhere in the lookup.
Okay.
Right. The tunnel is not associated with the port. Tunnel decap is only based on the fields in the packet.
Right. Yeah, I think this may need. Yeah, this is a little bit. I see what Krishna is saying here. This model is a little bit different than what even I have seen traditionally.
Yeah, everywhere I have worked for, like there was always a outer and inner world, even though most of the use cases only required global VRF for the outer, but there were use cases where the outer tunnels were independent VRF. So I think this is a bit of a simplistic model in that sense. Yeah.
Right. Right.
Yeah.
It looks like we have not hit a complex deployment to face the.
Yeah. So I think we'll get there.
Eventually, we'll get there.
Yeah.
Actually, the SAI tunnel term table entry has a VRID, but it's not clear how this VRID will be derived from the packet flow, right? The SAI tunnel term table entry does have an attribute called VRID.
For which tunnel types is it valid? Can you remind me?
Sorry, which?
Which tunnel types is this attribute valid for?
Oh, it's not specified, Marian. It's just
so for
valid only. Yeah. And the interesting part is, right, from a given packet, how would you derive this VR virtual router ID is not clear. Especially now, since we are trying to move this before the L3 lookup, right?
But actually, in this flow, we have the pre-ingress ACL table, right? In case if you want to set the VRF ID, you can.
Okay.
At least based on this flow.
Okay, so it can be an ACL-based VRF ID, but it won't be the incoming route interface-based VRF.
Yeah.
But I think we should still clarify how the default, I mean, in case ACL is not hit or not there, right? But where the default VRF ID for VRID will come for, because it's already in the termination.
I don't think
is it optional or let me see.
I don't think there is a default VRF. You can map VRF from in case of VXLAN, you can map it from VNI.
Okay.
We have these mappers and we have VNI to VRF mapper.
But that will be the inner one, right? That's not the outer VRF.
No, but there is no like outer VRF anymore after the gap because there is no outer.
No, but we do have that, like Ravi saying that, right? The VRID is part of the tunnel termination entry.
Yeah, it's a mandatory parameter.
So because it's mandatory, it has to come from somewhere, right? We could make it optional, but that would be a big change.
I see. In the API, you're saying there is a VRID.
Yes, a mandatory parameter.
I don't remember what it's for. Okay, I'll write it down. I'll try to clarify that item. So it's in the tunnel termination entry?
Yes, Marian.
Okay, thanks.
Tunnel term table entry. But I think this flow is much better, I think, right? One more, maybe I'll just go back and check, but to me, this looks better. Moving this tunnel decap early.
Yeah, logically, this is a much nicer flow, right?
Yeah.
Makes much more sense, yeah.
Regarding the metadata for the tunnel for the ACL, would that be a property of the tunnel ID or the VNI?
So, Avia, is it the new metadata that we'll be adding? Is that the question?
Yes. Yeah.
Yeah, so I think it can be part of the tunnel term table where we can say like a tunnel termination flag that we can set.
Marian, maybe the first table, right? Instead of calling it tunnel decap table, we might call it tunnel term entry table.
Yeah, that's how it's called in
Yeah, that's true.
termination. Yeah.
Then there's a tunnel table. The tunnel table points to tunnel map entry. Tunnel map entry. Yeah, tunnel table, and the tunnel table tells the tunnel map entry. Yeah. This flow specific to VXLAN. Okay, so tunnel map entry.
Yeah, there wasn't a GRE decap, but I can add one.
It's, but I think it's all similar. Maybe yeah. It'll be GRE key. You'll have to handle the GRE key.
Yeah, it's just that with VXLAN you have more options. With VXLAN you can go to L2 as
L2,
well. You can
L3.
map it to a bridge.
Okay, yeah. In the other case, you'll just have the LO flow, the router flow alone. So okay. GRE case.
But Marian, it will apply to GRE also, right? And some of the stages will be skipped, like the mapper table, but the flow applies to GRE as well, right?
I believe so, yeah.
But I'm just trying to map it to the SAI objects. What is the last box, right? The last purple box, tunnel decap map to
It's
the
just
SAI.
it's just the decap itself, like stripping. It's not in the SAI API. It's just stripping the
Just
headers.
stripping. Okay.
Rearranging the fields.
Okay. Just trying to think to extend this, right? Just whatever we have been doing for decap or termination, the same thing we might need in the origination case also, right? In the egress, I might want to know whether it's in a tunnel originated or not. Let me think of an example.
Again, if you say ACL, right, and if you're applying egress ACLs on the final outgoing packet, there might be use cases where someone may want to match on a tunnel encapsulated packet versus not. In the case the ACL is applied on the finally rewritten packet.
Yeah. Okay. Yeah. So I'm just trying to see if I just say match on a say source IP, does it mean it matches the payload source IP, or in the case of tunnel origination, would it match the payload source IP, or will it match the outer source IP address, right? When somebody just says match source IP. Today, what we are saying is in for tunnel origination case, in the ingress and egress stages, it's going to be for both. It's going to be the same. When I say match source IP, I'm always going to match the payload.
Are we saying that, or oh yeah, let's look at
in the pre-ingress stage, that's a difference, but in the ingress and egress stage, right? Either it's tunnel terminated or a plain packet, right? Both of the case in the tunnel terminated case, we'll be matching the payload packet fields in the ingress and egress stages.
Is the ACL?
So you're talking about the decap, or
I think decap, you're just saying in decap, just recapping whatever you explained, right, Marian? In the bottom two ACL tables, which represent the bottom right represents the ingress stage, and the bottom left represents the egress, right? In both of these cases, match on a say source IP or dest IP will match the payload fields.
Not on the left, right? The left table should match on the outer source IP.
No. In the bottom, whatever you're seeing in the bottom row, right? In the bottom row.
Yeah, bottom left table is after the packet modification, right? Or no?
No. Both are matching the payload fields.
Yeah, this is at least this diagram.
So this one is not doesn't show tunnel, right? In gap.
Yeah, there is no tunnel NCAP.
Okay.
Yeah. We're just saying for decap, what's the flow, right? Now we'll have to see similarly for NCAP, how does it look?
So yeah, so for NCAP, you have, so this is the VXLAN NCAP. In this case, it's from the bridge, but okay, so probably we need to name them. So this is the pre-ingress. Now we have this one and this one.
Egress port.
So this is the ingress. It's in the same place, and it will see the already modified.
So you are saying it will match the outer one?
Yes.
Because we pushed the NCAP early tunnel table entries.
Yeah, it's after the NCAPs. So yeah, this ACL should be the outer one, right?
Okay. This is after the NCAP, okay.
Because there's already one before the NCAP. So if you want to always match on the payload, then that one should be used, right?
Which one should be used?
This one. I don't know. This one looks like it's before the NCAP, the egress.
Yeah, I'm not sure which one it is mapped inside to.
Yeah, the stage is not clear.
I need to clarify that too.
It is after the egress because you already know the egress port, because the one before that says output interface is tunnel port. So yeah, all the egress lookups have been done on the payload.
Not really, right? Because the actual physical egress is going to be derived after the next stop.
It's not the physical egress. This is the tunnel.
Yeah. So you already know that you have already done the lookup on the payload, essentially. In this case, FTB L2 lookup, right? And the L2 lookup says go to tunnel. So this ACL will match on the tunnel port.
Not sure this one is mapped to SAI API. So this one seems to be clear, but this one with the tunnel port, not sure about that.
Yeah, what is the attachment point?
What's the stage, right? Even what's the actual stage, it's not clear.
Yeah, and also we have the tactile tableless egress port.
Marian, you had that table on the packet fields for the NCAP. Can you pull it up so that at least?
Sorry, I don't understand which table you're talking about.
The one which we were discussing on email. The packet field match criteria.
It was only for decaf.
We did not did for NCAP?
No.
So
maybe that's
the bottom table is before
I thought we did for
the next
NCAP as well.
No.
The other thing is that the table at the bottom here is before the next hop is looked up. So we don't know the outgoing port. So that table cannot be attached to the outgoing port. So
yeah, this flow does not look right to me, Marianne. It's the discrepancy in this. So packet comes in, it's a uncapped packet, right? So your pre-ingress will be on the original packet, which is not yet uncapped. Okay, lookup will tell us that. So we go to the L3 interface processing, right? So echo table, then go to a router flow. The router flow will do the lookup.
Hold on, you first go to the bridge because this is
this is L2 VXLAN flow. In the diagram shows L2
this example is L2 VXLAN.
Oh, this example is L2 VXLAN. Okay, I was just looking for the router flow.
Let's see if we have it.
A little bit easier to.
Yeah, I don't think we have a L3 VXLAN NCAP flow.
Yeah, but the L2 VXLAN should be working as well. So it
should be working as well, right? Yeah. So
So we do NCAP from FTB. After that, we go to the underlay route.
Okay, so here, your tunnel table. Okay, and after that, your tunnel NCAP has happened. Tunnel NCAP has happened, and you get the. So in this case, okay, so this one is before the router table. This is really confusing. So this becomes now pre-ingress, right? The ACL table at the bottom.
Yeah, that table at the bottom definitely needs to move to the left and after the next hop table, because then you get the egress port and you can attach the
Right.
table to the port. Yeah.
But that's ingress side. Why would move to the left? It's in the same place as every other router case.
No, but even in the other router case, right, and we can take a look at that, right? For the other router case, is the table simple the egress routing case? Is the ACL table after next hop or before next hop? Can you go to the egress? The simple
I think
routing case.
this is the ingress table. I think whatever Marianne has highlighted, that stands for an ingress, ACL stage ingress. Yeah.
That's the ingress stage?
Yeah.
I think I can clarify this, at least the way that I read it. This seems to me like a two-stage forwarding model.
Yeah. And you're doing a recirc after the NCAP.
Yeah.
Okay. Yeah. Makes sense. This is for the recirc case, because after the NCAP you're recirculating and the packet goes back to ingress pipeline, and that's what shows the ingress stages.
Well, that's a discrete pipeline. That's correct. We did the NCAP. Now we need to go to the router to do underlay routing. We need to do the routing on the IP header of the tunnel encapsulation as the logical model.
No, that part is correct, right? And you can either do with recirc and without recirc, right? The question is that would you apply ACL? Would you apply ingress ACL at that point again, or would you apply egress ACL? Because after the encapsulation, the packet is going out. You have to apply egress ACL, right?
I think
this needs
be able to do both.
Yeah, this needs discussion. So here, are you trying to create a two-stage lookup, or what are we trying to do? Because
I don't know what this two-stage lookup is. My point is that after you do any type of NCAP, GRE NCAP, VXLAN NCAP, you need to go to the router, right? You need to enter the router flow.
So today, right? So I think, let me just clarify what two-stage, one-stage is. So today, when the packet comes in and we do the NCAP process, while doing the NCAP process, the next hop resolution is done as if it's done on the NCAP packet, right? So we don't do first lookup, find out the tunnel next hop, and then do another lookup, and then find the actual egress port, right? So that's just the one stage. Two-stage lookup, recirc is your first pipeline is on the original packet goes NCAP, reinserted back in the ingress, and again goes through the full pipeline, right? So in that case, all your blocks get replicated.
No, it's not all your blocks. We have discrete blocks for the router, for the bridge. You may or may not go through the router twice. So if it's if let's say it's layer 3 NCAP case, right? For example, if it's GRE or L3 VXLAN, then yeah, you will do lookup first. You will get the tunnel next up. After that, you'll do the tunnel encapsulation, and then you'll go to the router again for the underlay. But like in this example, you go to the router only once because your encapsulation was derived from layer 2. It's not necessarily that you would go to the router twice.
No, Marian, we are saying the same thing, right? In either case, for the outer packet, we go to the router. The inner one,
of course, yeah, you have to go to the router.
Yeah. So I think we are saying the same thing. That the question is where will the ACL be, right? And for the final pass, when you go through the router, should the ACL be applied after the routing? Because the packet is going on an egress port now. And after the next hop table, you will know the egress port. So shouldn't the ACL be applied after that so you can bind that ACL to egress port?
But why would you? I think there is ACL after. There is one. It's not. It's just this diagram ends too soon. But if you take the router flow in general, there is also ACL in the beginning.
No, but then you have basically, if you think about this way, if I follow this diagram, right, there are 3 ACLs, then the 2 which are shown on this diagram, and
sure,
and the third one which is after, you're saying, right? So it's,
yeah.
And we don't know where okay, let's assume what you're saying is true, then the third one will bind to the port. What about the other 2? Where's the bind point for these tables?
So this one is router interface. This one is tunnel port, which I don't think we have in SAI API. This
but
one
again,
is
when
simple.
you say router interface, which router interface? Because you don't know the egress router interface yet, right? Because that will come after the next one.
No, that's ingress. That's the ingress side. This is your ingress riff. Egress is over there.
No, but what is ingress riff at this time? The packet has been routed, so why? And we have already applied the ingress ACL which matched to ingress riff on the same packet. So why would we do it again? I mean, the ingress table has already been applied.
Well, when you enter the router, you enter it through the router interface, right? Which is your ingress router interface.
Sorry, I'm in the mood for whatever you're doing. What are you saying? Between 12:30 and 12:40.
Sorry, I didn't catch that. Can you still hear me?
Yeah, we can hear you.
Yeah, we can.
Okay. Yeah, so whenever you enter the router domain, you always enter it through the ingress router interface. So if you enter it from the tunnel, we should be able to set the ingress router interface over here somehow. Let me see how we do that. It's not shown in here.
Can I ask more fundamental question? I think just the flow itself, I think it would be good if we create a baseline. So for a L2 VXLAN, forget the SAI pipeline, right? Just normal processing, what happens? Packet comes on a port, right?
Yeah.
Port is configured in a bridge mode. Is it a L2 or a L3 port?
For L2 VXLAN, yeah, it will be L2 port because it's a member of a bridge or a VLAN.
Okay, right. And then we do the FDP lookup, etc., and we found that there's a L2 encap. After the L2 encap is done, right? Now, ideally, right, you can either completely resolve the next hop or go through this forwarding where the encap lookup happens, and then we resolve the next hop. So question is, when we do the encap lookup, you really don't have an ingress port, right? This router interface which you are calling here after the tunnel encap, is this an ingress riff or?
It's not the port riff. I'm trying to remember what riff is this. It's not the port riff.
I mean, it can only be some kind of logical riff, some kind of tunnel logical riff, if we can derive it somehow.
Yeah, maybe I'll need to look up the SAI API. We should set this riff somewhere. It's not the port router interface. That's I'm sure of that.
Logically, it's the tunnel interface.
Yeah, so
Yeah,
the
but
tunnel
tunnel
table doesn't have a
interface,
riff, right?
yeah, tunnel interface is not, and it's already resolved. Tunnel is already done and over now. So at least, Marian, and I can verify the flow. Typically, when in the bridging mode, you do the tunnel in cap, okay, along with it, you will resolve. Either you can do another lookup or you will resolve to the next hop and straight away land up on the egress. And I think that's where the confusion is coming, that why you do need another ACL table. And can it be an ingress table?
No, hold on. It's not why you need the ACL table. It's that you're saying you resolve along with the tunnel, you resolve the next hop. I don't agree with that.
No, that's fine. And if we don't resolve, we do another lookup, right? Then lookup can happen, just as a forwarding information. You really don't have this riff binding. And if you have this riff, what you're calling, then curious to know, then how do we do that? Do we have ACL binding for this object?
No, so you're right, Jay, but only thing I want to point out is that, right, again, before you do a lookup, again, you need a VRF for the lookup, right, route lookup. So that VRF has to come from some riff. And that riff has to be set by the tunnel table. I mean, either riff or VRF has to come from the tunnel table.
I mean, VRF can come from the tunnel mappers, right? So there is a set VRF.
Okay, but that's
no tunnel.
That's a VNI. It's the reverse map, right? In this direction.
That's a VNI. Sorry, that's a VNI for this.
You only get the VNI in the mappers for M.
Right.
That's correct. So in order to get the VRF for the underlay routing, you need to get it from the router interface. And the router interface is the attribute of a tunnel from what I see in the SAI. Maybe it's not.
So Marian, I think that is what I remember also. The tunnel gives you a riff, and then from riff you can derive a VRF for the lookup, for the route lookup. What I don't get is that why is the ACL there? Because you don't attach ACL to that riff because that's a tunnel riff, and only purpose for that tunnel riff is to derive a VRF, from what I remember from.
Because all the router interfaces are the same. You can attach ACL to any router interface. I think that's the.
But then you have to remove the previous one. I mean,
which previous one?
The ACL table to egress port.
This one. I think it's not defined in SAI. So I will need to remember why this one is here. I'm also a little confused about this one. This one is just naturally here because this is the router flow.
So you basically apply two ACLs, right? One on the tunnel interface and the other one on the outgoing interface, right? So I think, yeah, those two I can understand. The ACL table egress port is basically the two tables which are currently shown in this diagram. Only one of them can be used. Only one of them can be applied on the tunnel, and the third one and the one should be after the next hop table, right? Which you showed earlier. But
one of them. Hold on, we have like.
Yeah, so that one is good. The one you just added.
Yeah.
The one I cannot get is the ACL table to egress port, because then you have three ACL tables and we only have two riffs essentially. There's the outgoing riff and then there's a tunnel riff. So you
So that's what I'm saying. I don't remember how this one is defined exactly because it's not on the riff. It's on the tunnel port, which I don't recall having that defined inside. So I would need to actually refresh my memory on this one because
you're right. But if you go back, I'm just trying to understand the diagram, right? What I don't get is what is the concept of tunnel port? Because if you just go up, right, you just follow the diagram before egress ACL. Yeah, right there. Just go down below. It says output interface
probably.
Is tunnel port.
Yeah, because what SAI API has, it's not tunnel port. It's when you go from so the lookup happens over here, right, in the FDB table that I'm highlighting. And what you get from this one is not as the result of the lookup. According to SAI API, you get tunnel ID or something. Or is it a bridge port? What do we get with the SAI API? if we would build the FDB entry for tunnel end, how would that look like? Let me just pull this one up. So we have our FDB. Where do we go from there? The FDB entry, MAC address, and bridge ID. And as the action, what we get as a result of the lookup is.
So there's an endpoint IP there, which is what I thought it gets, right? That you get an endpoint IP, which is the outer IP for which you do the route lookup, right?
No, but you need to get like the tunnel objects from somewhere. IP itself is not enough. You don't know
the
if
bridge
it's
port
GRE.
ID. I think the bridge port ID, the two attributes above. You also get a bridge port IP.
Yeah. So this is the bridge
that maps
port.
to tunnel. Yeah. Oh, so that port in there is the bridge port. Okay.
Yeah. Okay. So to be more specific, this is the bridge port.
Yeah. Okay. All right. That makes sense.
Hey, we're actually at the time, so
yeah. Sorry, Jai, you had a pull request as well.
Would we like to continue next week, next Thursday? Are you guys available?
Yeah. Oh, next Thursday. Okay, maybe someone is not. I'm just speaking for myself.
Who would not be available next Thursday? Okay, yeah. So then let's continue next Thursday then. Yeah, I think we could still discuss via email too, right, before that.
Yeah. Thanks.
Okay. All right. Thank you. Bye bye.